Picture a grand symphony orchestrated by an endless array of stars, planets, and moons, each contributing to the performance in perfect harmony. However, there is one particular segment of this cosmic symphony that has captured astronomers' attention for a considerable period: exoplanets. These are planets that exist outside of our solar system, hidden somewhere in or near the vastness of the Milky Way. It might surprise you to learn that amid the countless celestial bodies, there are strikingly similar exoplanets, so remarkably similar to Earth that they could potentially be our planet's cosmic counterpart. Allow us to enter Proxima B, an intriguing realm located just 4.2 light-years away. The James Webb Space Telescope is playing a key role in our quest to unravel these cosmic mysteries. Now, imagine traversing the enormous Milky Way galaxy, home to more than 4 billion exoplanets, a number that includes 15 zeros. To put that into perspective, if each of these exoplanets were the size of a grain of sand, they wouldn't just fill the Grand Canyon, they would go far beyond it. In fact, they could create a second monumental geological feature on Earth, a Grand Canyon 2.0. This enormous expanse of distance is surprisingly rich. Roughly 20% of these celestial objects have been referred to as Earth-like in terms of their geography and climate conditions. That indicates a 1 in 5 chance of finding a twin of our planet. And that's just considering the outside. These planets might also host quadrillions of moons, rocky satellites stuck in a dance of gravitation with their parent planets. Contemplating the possibility of discovering another celestial body that could host life, or might one day do so, is a reminder that the universe is full of possibilities. Now that we've laid it out, let's introduce the ultimate instrument for locating these intricacies on the cosmic scale, the James Webb Space Telescope. This cosmic detective, equipped with its large primary mirror made of flexible segments, surpasses even the most cutting-edge optical instruments available. This is no ordinary lens. It's 6.5 meters in diameter, nearly 2.7 times larger than the Hubble Space Telescope's mirror. Imagine capturing the tiniest hint of movement from a distant star billions of light-years away, and then analyzing the surrounding planets. What makes the James Webb Space Telescope truly revolutionary is not only its recognizing power but also its sophisticated technology, including state-of-the-art sensors and spectrographs. These instruments can do far more than just observe. They can analyze and process the light emitted or reflected by these massive constellations, allowing researchers to decipher their atmospheric composition, chemical balance, density, and even mass. Acting as a space-based scientist, the telescope can determine whether a planet contains water, organic compounds, or even oxygen. The James Webb Space Telescope has the remarkable capability to answer these questions, elevating it from a simple observer to a scientific genius. It is more than just an improvement over Hubble, it represents a quantum leap in our understanding of the universe. If Hubble's discoveries amazed you, prepare for a truly extraordinary era of revelations as we broaden our comprehension of the cosmos. Now we must focus on one particular star in this celestial narrative, Proxima B. Since it was first discovered in 2016, this enigmatic planet has enthralled astronomers and astrobiologists alike, drawing comparisons to a Shakespearean drama filled with complexity and intrigue. So, what makes Proxima B so appealing? It's incredibly close to our own galaxy, located within 4.2 light-years of Earth. To put this in context, if we could travel at the speed of light, it would take just a little over 4 years to reach it, roughly the same amount of time it takes for a TV series to become a cultural phenomenon. Now consider the importance of this closeness. In the vast plane of the universe, spanning more than 93 billion light-years end-to-end, discovering a planet so near and so ripe for scientific exploration is like finding a diamond in a mountain-sized pile of rocks, a precious gem that could keep important secrets about life. Proxima itself has the potential to modify everything we know about habitability and life beyond Earth. Not only is its proximity significant, but it also hints that it may not just resemble Earth, it could be Earth 2.0. Proxima B resides in harmony with what scientists call the habitable zone of its parent star, where conditions are neither too hot nor too cold but just right for there to be liquid water. Picture cascading waterfalls, winding streams, vast lakes, and possibly even oceans as mysterious and deep as the Mariana Trench. However, before we allow ourselves to conceive of traveling to Proxima B, we must consider a few characteristics that set this distant world apart. A single day on Proxima B is only 11 Earth days long. Picture dawns that not only mark the beginning of a new day but unfold gradually, becoming more leisurely afternoons and sunsets that linger, creating golden hours that photographers dream about. While this may sound idyllic, it also has significant repercussions for Proxima B's climate and its potential for supporting life. How would human biological rhythms adjust to Proxima B's light and dark cycles? Would we need to eat multiple times a day to accommodate the length of its days? Would our sleep patterns change? The patterns of life on Proxima B could be both remarkably similar to, and strikingly different from, our own, presenting us with a cosmic puzzle to solve. Nature has given us an enigma wrapped in a mystery, challenging our understanding of what makes a planet suitable for life. So how can we gather accurate and reliable information about a planet we have yet to visit? This is where the James Webb Space Telescope comes into play. Like a colossal Swiss Army knife, a sharper instrument for scientific investigation, it does more than function as a telescope. It is a powerful research facility floating in the void of space. With its innovative instruments, astronomers can not only observe distant planets but also study them through an array of scientific tools so advanced, they make even the most sophisticated earthly laboratories look simple. Using advanced spectrographs, the Webb telescope can examine the reflected or emitted light from these remote planets. Each element or molecule in a planet's atmosphere interacts with light at distinct wavelengths. By concentrating on these patterns, researchers can conduct a remote biopsy of celestial bodies, revealing vital information regarding atmospheric pressure, composition, and the potential presence of life-sustaining compounds such as water, carbon-based molecules, and even oxygen. Space science isn't just about studying distant stars. It's more akin to space forensics. Researchers don't wait idly for clues, they actively search for them, analyzing the atoms and molecules that form these distant worlds. The Webb telescope is more than just an indifferent observer, it is an exceptional research lab, a specialist, and an extensive analyst all rolled into one. It allows us to evaluate our hypotheses about distant worlds, offering concrete data that can either confirm or challenge our theories. And just when we thought we had uncovered all the mysteries of this cosmic exploration, something unexpected happened. Researchers using the James Webb Space Telescope detected an astonishing signal. An astonishing signal that defied initial expectations. At first, it appeared to be nothing more than background noise, just another flicker in the vast sea of cosmic data. But as researchers began to filter and isolate the signal, something remarkable emerged, a repeating pattern. This wasn't the kind of rhythmic pulsing associated with pulsars or the electromagnetic bursts from black holes. No, this was different, subtler, almost deliberate. A narrow band of frequencies echoed every 11.2 Earth days, the same duration as a single day on Proxima B. The signal wasn't just repeating, it was synced. Speculation rippled through the scientific community. Could it be geological? A magnetic interaction between Proxima B and its star? Or something more, artificial? To rule out earthly interference, the team cross-checked data from multiple observation points, across different instruments, in different countries. The pattern held firm. And so, the once routine mission of observation shifted. The James Webb Telescope was now locked onto a new objective, to understand the origin of this signal. High-resolution spectroscopy was employed, breaking down every wavelength, every fluctuation. The data that returned was subtle but compelling. There were fluctuations in carbon monoxide, traces of methane, and, most astonishingly, minute quantities of free oxygen. Oxygen in isolation wouldn't be significant. But in combination with methane and carbon dioxide, it suggested a planetary atmosphere not unlike Earth's. More importantly, this mix of gases, constantly replenishing each other, pointed to one possible explanation: biological activity. Whispers began circulating in academic circles. Could we be observing not just a habitable planet, but a living one? Plans for future observation missions were accelerated. The European Extremely Large Telescope was scheduled to follow up, and private aerospace companies, sensing history in the making, began investing in new propulsion technologies, just in case. Somewhere, 4.2 light-years away, on a rocky exoplanet bathed in the dim red glow of Proxima Centauri, something was stirring. Whether it was natural or artificial, geological or biological, one thing was certain. Proxima B had become more than a curiosity. It was a message from the universe, a whispered question echoing across time and space. Are we alone? And for the first time in human history, we might just be close enough to answer. From Proxima B, a signal so intricate and unusual that it brought about excitement and debate across the scientific community and social media. This signal was dubbed a potential techno-signature, an electromagnetic emission that was so strange and complex that it raised the possibility of advanced technological civilizations. For a brief time, it appeared as though humanity's collective pulse had paused in awe. Could this be the breakthrough discovery proving that we are not yet the only ones in the universe? As soon as the signal was received, it vanished, leaving behind a profound silence and a multitude of unanswered questions. Was this just a cosmic fluke, an oddity of nature, or could it be something more thoughtful, perhaps an encrypted message or signal from intelligent beings on other planets? This solitary signal has left a cloud of mystery surrounding the explosion of interest in Proxima B. Fierce debates and theories about its origin raged. Was it a brief blip, or could it be part of a larger narrative, one more intricate than we can even imagine? But the narrative doesn't end here. The search for answers continues, and now it's not just ordinary scientists, but Harvard researchers who are pushing the boundaries of our understanding. They are transforming instruments into a kind of James Webb Space Telescope cosmic night vision instrument, looking for artificial light sources in both the dark and illuminated regions of distant worlds. The possibilities are staggering. Imagine spotting the city lights on planets far away, their lights shining through the darkness like beacons of advanced civilizations. It's not only about the search for life, it's about locating evidence of intelligent beings influencing their surroundings in ways that we might not have taken into account. As we dig deeper into space's vast expanses, the search for alien life on other planets takes on new dimensions. This search, fueled by rapid advancements in technology and a deep curiosity about our place in the cosmos, drives us to explore beyond Proxima B and into the universe's farthest reaches. Instruments like the James Webb Space Telescope, alongside ground-based observatories, provide unprecedented understanding of exoplanets, which opens up new avenues for discovering life and understanding the potential habitability of these distant worlds. Among the most intriguing areas of exploration is the search for biosignatures, chemical markers in a planet's atmosphere that could point to biological activity. This could consist of gases such as methane or carbon monoxide, which, under the right circumstances, may point to the presence of life. With the capabilities of the James Webb Space Telescope, scientists can now examine these chemical signatures with amazing precision. Through studying the starlight that filters through an exoplanet's atmosphere, astronomers can identify key molecules, water vapor, ozone, and oxygen, that may indicate conditions suitable for life. In addition, the study of the environment of these planets is essential for models based on Webb's data, helping to predict whether a planet's temperature may permit liquid water, which is essential for life as we know it. Planets in the habitable zone of their stars are of particular interest since they may have the right conditions for stable liquid water to exist. The search also extends to moons orbiting these exoplanets, some of which may contain oceans beneath the surface of their icy crusts, much like Europa and Enceladus in our solar system. Beyond biosignatures, the concept of technosignatures is gaining momentum. These are possible evidence of extraterrestrial technologies, whether it's big energy harvesting structures like Dyson spheres or strange radio transmissions. As we refine our observational techniques and build greater international cooperation in the search for technosignatures, we could provide the long-sought evidence of advanced alien civilizations. Cooperation plays a vital role. Collaborations between space agencies, research institutions, and private businesses are improving our collective ability to explore space. As we pursue missions to Mars and other celestial bodies, nations are pooling resources and expertise to reach new heights in space exploration. Public engagement, too, is essential for maintaining excitement, inspiring the next generation of engineers and scientists to continue the search in the universe for life. In conclusion, the exploration of exoplanets and the search for life on other planets is a dynamic and rapidly evolving field. With every advancement, we edge closer to answering humanity's most profound questions about our place in the cosmos. As we continue to investigate the stars, the potential for the discovery of novel forms of life and gaining a deeper comprehension of life in the vast universe is an exhilarating and boundless journey. This quest for knowledge is more than just an intellectual pursuit, it's a testament to humanity's curiosity and our need to communicate with the universe in a significant manner. With each new discovery, we challenge the very notions of life, intelligence, and the nature of existence within such an expansive universe. Whether it's through the detection of chemical signatures in distant atmospheres or the potential observation of alien technologies, the hunt for extraterrestrial life continues to captivate our imaginations. The implications of finding life beyond Earth would not only redefine our understanding of biology but would also reshape how we view our place in the grand tapestry of existence. As we venture further into the cosmos, the questions about our place in the universe grow even more profound. The potential discovery of extraterrestrial life, whether microbial or intelligent, could challenge the very foundations of our understanding of life itself. It could redefine our definition of what it means to be alive, as well as open up new possibilities for interstellar communication and collaboration. The thought of civilizations spanning across galaxies, each with its own unique culture, technology, and way of life, is both humbling and awe-inspiring. As humanity continues its journey through space, the lessons we learn may not only reveal the existence of life beyond Earth but also teach us about the fragile nature of our own existence. The search for extraterrestrial life serves as a reminder of the importance of protecting and preserving our planet, as we are not the only sentient beings in the vast universe. The delicate balance of ecosystems, the preservation of biodiversity, and the protection of our resources become all the more pressing as we consider the possibility that other worlds may face similar challenges. This search also reminds us that we are part of something much larger than ourselves. The universe, with its infinite stars and galaxies, is a vast and mysterious expanse, and we are just a small piece of that grand puzzle. Yet, despite the seemingly insurmountable odds, we continue to explore, driven by a desire to understand our origins, our future, and the place we hold in the cosmic order. The potential for contact with other intelligent life forms could reshape not only our scientific and technological pursuits but also our philosophical and ethical frameworks. How would we interact with such beings? What would it mean for human identity and society to know that we are not alone in the universe? These questions touch on deeper issues of morality, cooperation, and the nature of consciousness itself. In the coming decades, as our technology advances and our understanding of the universe deepens, humanity may stand on the brink of one of the greatest discoveries of all time, the proof that we are not alone in the universe. But even if we never make direct contact with extraterrestrial life, the search itself will continue to inspire and fuel our collective imagination, driving us toward new discoveries, greater understanding, and a deeper connection to the cosmos. The hunt for alien life, the exploration of distant exoplanets, and the search for technosignatures are all part of a larger human endeavor, an endeavor that transcends borders, cultures, and generations. It is a pursuit that reflects the best of what humanity has to offer: curiosity, resilience, and the unyielding desire to explore the unknown. And as we continue on this journey, we are bound to discover not just new worlds, but also new ways of thinking, being, and understanding our place in the universe. Thus, the quest for extraterrestrial life is not just a scientific mission, it is a philosophical, ethical, and existential journey, one that has the potential to change the course of human history forever.